I'm going to talk a little bit about a trapezoid. A trapezoid is a quadrilateral, so it has four sides. And it has two sides that are parallel. And the sides that are parallel are called the bases. So in a trapezoid, there are two bases. And the sides that are not parallel are called the legs. So yet again, another use of the word leg. So in a trapezoid, there are two bases and two legs. And one thing that is true about a trapezoid is that if you have parallel sides, wherever you draw an altitude, so an altitude is a segment that's going to be perpendicular to the base, whenever you draw the altitude, it's true that the altitude, no matter where you draw it, is going to be congruent. And here's why. Because when you draw an altitude, if you notice what we've created over here, so what I've created over here is in fact a quadrilateral. And I know that I have in this yellow quadrilateral that I've created, I have parallel sides right there, and then I have right angles. So in fact, I know I'm going to have same side interior angles being supplementary. So if this is a 90-degree angle right there, this one also must be. And if this is a right angle, this one must be. So we end up with a rectangle, and we know that opposite sides of a rectangle are always congruent. That's something you know. So this is a little fact that we're going to use about properties with trapezoids that have to do with the Pythagorean theorem. So here is a typical problem that we're going to have. You might have a trapezoid that is drawn, and it's going to look, in fact, I'm going to draw a trapezoid that looks a little not traditional. I'm going to say that this side is x, and let's see, this leg is 12. These are going to be parallel. In fact, I'm going to put it in right angle. So, and let's say this is 6 and this is 10. And we need to figure out what x is. Well, we have no idea what x is, but here's what we can do. We can draw an altitude, and I'm going to draw an altitude right there. And what I know is that if this is 6, so I've created a rectangle here. If this side is 6, then this side is going to be 6. And out of the 10 inches we have for this side, I know 4 will be left over right over here. And now I have created a right triangle. The hypotenuse is 12. One leg is 4, and since this is x, this side will also be x. So we can use the Pythagorean theorem. X squared plus 4 squared is equal to the hypotenuse squared, which gives us x squared plus 16 is equal to 144. And if I subtract 16 from both sides, that's going to give me x squared is equal to 128. I'm going to square root both sides. And the one thing I know is that 4 goes into this. 4 goes into 129, 32 times, and 32 is 16 times 2. So I have a whole lot I can pull out. From the 16, I'm going to pull out a 4. From the 4, I'm going to pull out a 2. So I know x is going to be 8 times the square root of 2. And I'm going to do another example as well. An isosceles trapezoid is a trapezoid with congruent legs, so you might have something that looks like this. So this might be 11, say this might be 13, 13, and this bottom base might be 21. And I might be looking for the altitudes. I might be looking for this. So that might be x. Well, what I know is that if I draw the altitude, each one is going to be x. And let's see, if this top piece is 11 right over here, then this bottom piece is going to be 11 because I've created a rectangle. So then I have 5 units left over from the 21. I'm sorry, 10 units left over, but that's going to be 5 on each side. And then, in fact, I can just use the 5, 12, 13 triplet, so I know that x there must be 12.